Alright, ladies and gentlemen, in this video we are going to analyze a system of inequalities from real situations. So we are going to have the graphs already provided for us, and in fact I'm going to have the inequalities not only provided for you, written for you here, I will also have them solved for y, so that we will have all of that work done. Our main goal here is to understand what the graph means. Remember, when reading graphs, understand what the y-axis represents, what the x-axis represents. That's the whole thing to reading graphs, whether it's in your math class, science class, or on a standardized test like the SAT. So in this case, I know any of these numbers on the x-axis represent the number of pies, and any of the numbers on the y-axis represents the number of pumpkin pies. Apple pies on the x, pumpkin pies on the y. In our word problem, we're getting all of our pieces of information. This is how we wrote our inequalities and then solved for y, but we still need them after writing them, or if they've been written for us, because we need this information. She wants to make apple pies that sell for $3, pumpkin pie that sells for $2. That's going to be really important information that we're going to utilize as we move on. Now, use the graph to answer the following questions using complete sentences. Again, I'm not looking for anybody to win a Pulitzer Prize for their writing. I just want sentences. So, could Bella make 5 apple pies and 9 pumpkin pies? This is just identifying whether that is a solution on the graph, but you have to go to 5 apple pies along your x-axis is apple pies. So I'm going to this 5 and 9 pumpkin pies. That's this 9, and let's identify where those meet. I'm essentially looking at that ordered pair, and I'm deciding if that ordered pair is part of the solution set. In this case, it's not. It's not in that dark shaded area. So that's all I'm asking you to write is no, because that point is not in the dark shaded area. If I had asked you to be more specific and state why is it not, that's when we'd have to go up here and analyze these. And we could see that 9 and 5 is 14. 14 is not less than or equal to 12. So that would make 14 pies, which is not less than the, or not at most 12. Going further, how much money would she make if she did do 5 apple pies and 9 pumpkin pies? That goes back to the word problem up here, and recognizing that apple pies are $3 and pumpkin pies are $2. I need to utilize that here. Apple pies we said were $3, and pumpkin pies we said were $2. That's a multiplication problem, so I know that if we did 3 or 5 apple pies at $3, it's $15. 9 pumpkin pies at $2, we're getting another 18. That's an addition problem. We add these together, she would have had $32. Essentially, I am substituting those in to my second equation. We can see that is greater than or equal to 20, so that would have been okay, but it didn't meet the criteria for the first inequality. Go ahead and press pause and try the second example here. 9 apple pies, 2 pumpkin pies. How can you tell from your graph? And then answer part D. When you're done, unpause to check your answer. So yes, she can make 9 apple pies and 2 pumpkin pies because that is in the dark shaded region. We can see that up here. 9 apple pies, or 2 pumpkin pies, 9 apple pies, it's in the dark shaded region. We can also tell from the first inequality, 9 plus 2 is 11, that's less than or equal to 12. The second inequality is what we understand by answering part D. And at $3 and $2 respectively, we wind up at not 32 this time, but $31, which once again meets the criteria for the second inequality that the cost has to be greater than or equal to 20. Our second example on these notes is similar, but there is some slight differences here. The first part is the same. Parts B and part B is the much more difficult one. So I want you to do part A, try part B if you can, and then try part C. I'm going to go over A and C quick and then come back and kind of finish up with part B. So press pause and try A, B, and C, and be ready to go over B in detail. Alright, so here's our answer for part A. Yes, it's in the dark shaded region. Now, part B, let's go over this in detail because the wording here can be confusing. Very specifically, it says that she is going to bake cinnamon bread only. Only cinnamon bread. That means how much banana bread is she going to bake? Hopefully you said none, because that's correct. If she's only baking cinnamon, her banana bread is 0. So the key there is I want to go to the banana bread on my x-axis and go to 0. I need to know where is the biggest number that is still a solution when banana bread is 0. All of these numbers are big numbers, but none of them are solutions. These numbers are big numbers as well, but they're not a solution to the system. They're only a solution to one. They're not in the dark shaded region. So I have to focus on that point right there. That point is representing the solution to this system, because 0 banana bread, 12 cinnamon bread, that's the most we can possibly make and still be in the clear for the amount of money that we're going to make. So 0 banana bread would be 12 loaves of cinnamon bread. 0 banana, 12 loaves of cinnamon. The word problem told me that cinnamon bread was $2 each. So at a $2 price range, I multiply this for a total of $24. And you can see if I had gone higher than that, 13 loaves would have been $26, no longer meeting my criteria. Part C is a little bit tricky too. I'm going to leave this up there for now and then talk about this. She's going to do both. So which spot would represent the most? Maximize your amount of bread for each while still being in the solution set. So again, I'm focused on only the dark shaded region. And up here, I'm only making 12 loaves of bread because I'm doing 0 banana, 12 cinnamon. So we want to find the spot where those two numbers add up to be the biggest possible. And in fact, that's always going to be the intersection point. Here it's 12 banana bread, 3 cinnamon breads. Okay. 12 and 3 is 15. There's no other combination in the dark shaded region, which represents our solution, that'll be bigger than that. So that's what we get as our answer. 12 loaves of banana bread and 3 loaves of cinnamon bread. And again, the prices from up top, our banana bread's $1.50 and our cinnamon bread is still $2. 12 times $1.50 plus 3 times $2. There's our magical $24. I've just maximized everything. I've sold my 15 loaves of bread and I made my $24.